Good day. In this lecture, we go to chapter 2 of Matlab programming. It's on numeric arrays. And this chapter is basically going to be in test 2. 2.1, one-dimensional and two-dimensional arrays. First, how to create vectors. Vectors are one-dimensional arrays. A vector can be row vector or column vector. To create a row vector, for example here, A is a row vector. It has 4 elements. You just type in this way. You can use comma or blank spaces, one or more blank spaces to separate between data elements. So in this command window, Octave compiler, for example, I'm going to create A. Here I separate the data using blank spaces. You can also use comma to separate between array elements. The colon operator. When you have regularly spaced elements, you can use the colon operator to create the vector. This is the syntax. M is the first element of the vector. N is the last element of the vector. And Q is the increment. Q can be positive, can be negative. For example, here we have A start with 2, ends at 8, and is incremented by 2. So we have the first element 2, plus 2, 4, plus 2, 6. The last element, of course, 8. So you can create the A vector. This can keep in B. The first element is 4. Increment is 1. And with 8. So the spacing is regular. Plus 1. If you omit this, by default, it's going to be plus 1. Omitting this, it's going to be plus 1. Only the starting and ending value. Of course, the step can be negative. For example, of course, you start with a high value. The first element is 8, then reduce by 2 up to 0. This is the last element. When the spacing between array elements is constant, in other words, linearly spaced vector, you can use the function linspace, where x1 is the first element, x2 is the last element, and there are n elements, including x1 and x2. For example, here, linspace 2, 6, 5. So the first element is 2, the last element is 6, and there are 5 elements. So you go to CLC, clear the screen. Let's see. First element 2, last element 8. Let's say there are 10 elements. So in this way, starting value 2, ending value 8, and there are 10 elements of X. So the increment is determined by Octave or Matlab. So of course in this case, sorry, we should use the, there's no lin space there. This is just a normal vector. It should be, this one is just a normal vector. So this lin space, start with 2, end with 8, and there are 10 of them. So the spacing is basically 0.6667. It's determined by Octave compiler or Matlab compiler. This one is just a regular row vector. To create a column vector, there are 3 methods. One is using the semicolon between elements. So 5, 8, 9, in between we have semicolon, will produce this column vector. Or you can type a row vector using the transpose operator, single quote. Or you can physically type the vector as a column vector. So this will create, of course you can put a spacing there. So this is going to be a 4-element column vector X. Of course, you can type a row vector and transpose. It will also produce a column vector. Or you can physically type the elements of the vector. See, nothing happened because you have to close with another square bracket. 3, let's see, 5, 7, 8. You don't have to align, it can be offline. I just want to make it pretty. So you get your column vector. This is okay for short vectors, but if the vector is very long, probably you have to use this one or this one. 2D arrays. A 2D array is also known as a matrix. And a 2D array has a dimension, m rows and n number of columns. In linear algebra, we just call it m by n array. It has m rows and columns. How to create matrices? There are 2 ways. One is typing the row and then using the semicolon to go to the next row, new row, this second row. Or you can physically type the elements of the 2D array. To clear the screen, let's see, normally for row or column vectors, we use lowercase. Uppercase is for matrices. Let's say first row, second row, third row. So I have the 3 by 3 matrix A. Of course, you can physically type the elements in the matrix. For example, 4, 5, 7. You don't have to align. The column need not be aligned. It can be off alignment. So we also produce a 3 by 3 matrix or 2D array. Transpose operation. We've seen before in the example. Of course, first row, go down, this second row, transpose. So basically, you will change this initially 2 by 3 matrix. Transpose, you get a 3 by 2 matrix. where basically rows become columns, or columns of the original array become rows. For example, here, see, I'm going to transpose B. So first row become first column, second row become second column, and third row become third column of the new matrix C. Array addressing. Here we have row vector, 4-element row vector, and A is a 3 by 3 2D array or a matrix. So you can type this in the command window and then issue each of these command in the first column. So A, full column, means all rows and columns of A. So the output is going to be in this form, in the form of a column vector. Next, vector A, column 2 to column 3. So it's going to be 8, 9. The answer is 8, 9. Matrix A, all rows, comma, but column number 2. So all rows, but only column number 2. So the answer is going to be a column vector 504. Next, for matrix A, row 1 only, comma, all columns. So row 1, this one, all columns. So it's going to be 358. Row vector 358. Next, matrix A, all rows, but columns 2 to 3 only. 2 to 3. So all rows, everything, but column 2 to 3 only. So it's going to be 580246. Next, matrix A, rows 2 to 3. So this one only. But the column is going to be 1, 2. So the answer is going to be 7014. It's a new matrix, 7014. If you type A, full column, this will create a vector by stacking columns of A from first to last. So basically, it will return 371. This is going to be stacked below. This third column is stacked below the last one. Let's say this is our matrix A. If I type C, is going to be A, full column, all, basically all. It will stack 478, 500, and last one is going to be 790. And last row of A, all columns, or full column, this is all rows, last column. Clear this window. See, if I type A, N, so I want to access the last row, all columns. So it's going to return row vector 0, 0. If I type all rows, last column, this all rows, last column of A. So it's going to be all rows, basically everything, but last row. So it's going to return a column vector 790. Why NS? Because we did not assign the results to any variable. So the default variable is going to be ANS. Unless, of course, you assign to any variable name, then it's not going to be ANS. Array functions. Find X will return the address or the indices of non-zero elements of array X. You see, this is X, first element, second element, third element, fourth element, fifth element. Find X will return not the values, it will return the address. This is S1, S2, S3, S4, S5. So it's going to be the non-zero elements of X. The first one, third one, and the fifth one. So 1, 3, 5. That's the address. To get the values, you know the address. So you just type, for example, the values, the non-zero values. It's going to be for matrix X. This is the address kept in ANS. So you have the non-zero values. X1, X1, 9, X3, 4, X5 is -5. Of course, if you have a matrix, find will return also the non-zero elements of A, but the position is going to be linear. Remember our matrix A? If you just type find A, it will return the non-zero the position, the index. But index is going to be linear. What I mean by linear is linear addressing is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will return the non-zero elements are 1, 2, 3, 4, 7, 8. 1, 2, 3, fourth one, 7th and 8th. To get the values, of course, use the address. A operates on the address. We return the non-zero values. Also, return in a linear fashion. 4, 7, 8, 5, nothing here. 7, 9. Based on this position, linear position. For more complete information, for example, which row, which column, and the values, you have to use this syntax. U is a vector on the row position, V is vector on column position, and W is the non-zero values of matrix A. This A. This is just the variable name. The first vector is going to be row information. The second vector is going to be column information. Third vector is the non-zero values. I call it val. So find A. So we return in this form. On row information, this is first row. This is second row, third row. The processing is still in the linear fashion this way. Of course, third one, this is in the first row, nothing here. This in the first row, and the last one is here in the second row. The same with column. This, all these three, first column. This is second column. All these two going to be in the third column, and the values also the same. 4, 7, 8, 5, 7, 9. But to make it clear, I can stack the row, column, and values in a table. For example, I'm going to call it tab for the new array. I'm going to print the row information here, the column information here, and the values vector here. So this is our matrix here. What I did was just to stack is the column row vector, column vector for the non-zero values of A. So you can see here, where is 4? 4 is in row 1, column 1. Where is 7? This 7 is second row. Sorry. This is 1, row 1, column 1. This 4. This 7 is row 2, column 1. This 8 is third row, column 1, and so on. Length. The function length gives number of elements when A is a vector. When A is a matrix, it will give this is the bigger value between M and N. M, remember, number of rows, number of columns. Length effects. You return the number of elements, 5. So X has 5 elements. But not for a matrix. Let's say matrix B here. You can use the arrow key to go to the previous command. B. It will return the size of B is going to be 2 by 3. It will return the bigger value between rows and column. So it returns 3. But we go also to size, because these two are related. Size is going to be the dimension of an array. Size of X is going to return 1 by 5. Size of B is 2 by 3. Dimension of an array. Maxed. The function max, if A is a vector, it will return the largest element in A. If A is a matrix, it gives row vector with largest element in A, column by column. Next, max, X returns what? It returns 9. B, just now. Max B. It will return the largest value for each column. So the answer is going to be 578. It returns by column. In other words, for this column, the maximum value is 5. For this column, maximum value is 7. For this column, maximum value is 8. Min is just the opposite. Min is the minimum value instead of maximum value. Of course, for a matrix, we also want to know the maximum value, for example, in what row. So you have to get a complete information, you have to use this syntax. The first vector is actually the maximum values. The second vector is going to contain information on the row information. So value, comma, row. See? For example, maximum, this is just a name, a variable name to store the results, maximum value. And for example, row information. Max. Okay. For maximum values, it will return also by, still just like before. If you type max A, it will return by column the maximum value. But this second vector contains the information on the which row. So this is in the third, you know this column, but it's in the third row. 5 is in the first row of this column, and 9 is the second row in this column. Min is just minimum value. Norm will compute the magnitude or geometric length of vector x. This is x. So norm of x, you just calculate the square root of 9 squared plus 0 squared plus 4 squared plus minus 5 squared square root, so you get this value, magnitude of a vector. Size we have seen before is just the dimension of an array. Sorting will sort by default each column of A in ascending order. This is A. Just sort A. It will sort by column in ascending order. From small, for this column, it's going to be 578, because it's going to be 005, from small value to large value. For each column, 7 is going to be sorted as 7079. The full syntax is going to be, this is the full syntax. One is for column sorting, ascending order. You can delete this, or delete this, keep this, or delete two of this, you still get the same answer. This is the full syntax. Of course, if you want to sort in descending order, you have to type this. This is going to be, for each column, the sorting is going to be from large to low. How to sort by row? To sort by row, you have to change this number to 2. A. Sort A. Column sorting. If you don't put ascend there, it's going to be ascending. By default, it's ascending. This is the full syntax. Ascend. So it's going to be, for this row sorting, 457. Second row, 709. Third row, of course, 008. Of course, you can change this to descend. So it's going to be row sorting, descending order, from large to small for each row. Sum will add up elements in each column of array A. Of course, if A is a simple vector, then sum is just the summation of all array elements. It's x before. Sum of x, it will not return, for example, this column 9, this column. No, it's going, because this is a simple vector, it will calculate, it will add up all array elements. Only for matrices, for example, this A, sum of A will add up per column. So you get this. For this column, total. For this column, total. For this column, total. Let's say I want to add up all these elements. How? Simple way is just, of course, this ANS, sum ANS, of course, you get the total. Because we did not assign this to any variable, so it's kept in default variable, ANS. total is actually 40. Or you can combine in a single operation. Total is going to be, let's see, total sum of A. You will produce summation for, if this will produce a row vector of summation for each column, and then we add up all the, for that vector we add up using also the same function, so you get the total. So basically you can go through these notes. Next, element by element operations. This is a very important concept in Matlab. You can add scalar, B is a scalar, to an array. For example here, this row vector, we are adding this element to this scalar quantity. So 6 plus 2, 8, 3 plus 2, 5, you get a new row vector. The same with subtraction. For array addition, the array has to be the same dimension. For example, you cannot type 6, 5 plus 4, 8. There's another element here, 4, 8, 9. This 1 by 2. This is 1 by 3. You cannot add. It has to be element by element. The position must match. 6 plus 4, 10. 5 plus 8, 13. The same with subtraction. For array multiplication, you have to use this symbol, the dot operator. This indicates the operation is going to be on element by element basis. So this is going to be 3 times 4, 12, 5 times 8, 40, element by element. Without this, it's going to be a matrix operation. We cannot multiply this matrix by this matrix because the dimensions don't agree. Right division, element by element. So it's going to be 2 over 4, 5 over 8. Left division, 4 over 2, 8 over 5. Exponent, you can have array raised to the power of a scalar. You must use the dot operator. The same with the scalar raised to the power of each array element, or first array raised to the power of second array, element by element. So it's going to be 3 power 2, 5 power 4. Adding to a vector, this is a vector, plus 3. Number A, I'll keep it in a new matrix B. I'm adding, for example, scalar to this array. The same with subtraction. Multiplication. For example, it's going to be 2 times 3, 3 times 3. Of course, you don't have to put the scalar at the back, it can be at the front. However, if you have two letters, you cannot, for example, 2 times 4, 3 times 5, you cannot write it this way because this is going to be a matrix operation. It's illegal. So what we have to do is put a dot there. We are saying multiply, but it's element by element. First element of this array times first element of this array, second element of this array times second element of this array. 2, 4, 8, 3, 5, 15. The same with right division. 2 over 4, 3 over 5. Element by element. Left division. 4 over 2, 5 over 3. Exponentiation. Let's say this array, simple row vector, raised to the power 2. So we're saying 2 raised to the power 2 is element by element, 3 raised to the power 2. This is going to be 2 to the power 2, 2 to the power 3, element by element. So it's going to be 1 power 3, 2 power 2, 3 power 4. It's element by element. The same with matrices. Example here I have this matrix. Of course, addition is simple. You just add, but not multiplication. Of course, multiplication, if you type, for example, A times B, this is just a normal matrix operation. You can do this because this is 2 by 2, this is 2 by 2. The product is going to be also 2 by 2. This is a matrix operation. This is element by element operation. So it's going to be this element times this element and so on, element by element. So A, elements of A raised to the power of elements of B on element by element basis. This is a matrix operation. It is illegal. How you cannot trace the power of a matrix, raise to the power of another matrix, even not even defined. Doesn't make sense. So you must understand this concept. Very important in Matlab. Finally, in this example, so your test 2 question for Matlab part is going to be more or less similar to this. For example, here we have 5 tracks, 1, 2, 5. The distance covered for each track and the time taken to complete the journey. And we want to calculate the speed of each track. So speed is just distance over time. Distance covered over total time taken. Basically, we want to divide this by this, this by this, this by this to get the speed of the track. Find also the track with the highest speed and total distance traveled by all tracks. Using Matlab is very simple. I'm going to keep this in a vector. I call it D for distance. You can call it anything, X or Y, but D is a lot better because it is also for distance. So D is going to be 300 for track 1 up to the last track. T for time taken, 3 up until the last one, 4.2 hours. So speed, basically we want to divide element by element of D array vector by the time vector. This over this, this over this, this over this. So it's going to be speed is just this vector D element by element divided by this vector T. So this will give you this output. So this is speed for speed 1, 2, up speed 5, speed of each track. To get the highest speed, track with the highest speed, you have to use this syntax. Maximum value, comma, index. The position of this, the highest value in this array. Of course, the function is maxed. operates on this vector, speed, 0 vector. So it will return higher speed 100. The position is actually speed 1. So the index is 1. Of course, the index matches with the truck ID. Total distance, you have the distance vector. So you just add up 300 plus 250 plus 100. Remember the function sum? So total distance is just sum of all elements in this vector d. Sum d gives you total 1650 kilometer. So very quickly, I'm going to demonstrate this. Clear memory, CLC, clear screen. So distance vector is going to be you can use comma to separate array elements. I'm using blank space to separate array elements. 420, 280. I don't want to display the distance vector. Put a semicolon at the end. It's not displayed. Time taken 3 hours first drop, 2.8 second drop, third, fourth, last drop, 4.2 hours. Okay, I don't want to see the display of this vector. Put a semicolon there. So speed, it's just going to be element by element, remember, of d divided by element, each element of the corresponding element in t. Of course, you don't see the bracket there, square bracket, but you have to imagine it's a square bracket there because all numeric arrays in Matlab are matrices. And of course, vectors are subset of the matrix. So, to find the truck with the higher speed, so maximum value here, so I'm going to call it max speed. Comma. You can use, for example, because truck number also is actually the index, the position where this value, maximum value occurs. I can use any variable name, I, j, k. So max, operate on the speed vector. So returns maximum speed 100 by truck number 1. Total distance, I'm going to put total distance, not this, just sum of the distance vector. Of course, to find the truck with the minimum speed, change this to the slowest truck. Which one? This one. It's truck number 4. So your test 2 question for the Matlab part is going to be more or less like this example. Thank you.